Yesterday, we looked at numbers and changed them from scientific notation to standard form, and then we went the other direction, didn't we? We went from standard form to scientific notation. Today, we're going to multiply numbers that are written in scientific notation. This may be something that you would find maybe in a science situation where you have two really small numbers, maybe two really big numbers, two measurements that are written in scientific notation, and you need to multiply them. Now you could change both of these to standard form and then multiply them, but here's where it gets tricky. When you have all those zeros to multiply, then you multiply another number with all those zeros, it gets crazy trying to count up all those zeros. So there is a more efficient way to get to that answer, and that's to use your exponent rules that you guys already know about. In problem A, that's on your note sheet, you will notice that we are multiplying everything in this problem, correct? You agree? Parentheses mean we're multiplying. This times sign here means that we're multiplying. Multiplication is commutative. What does that mean?
You can reverse the order and change it.
We can change around that order, can't we? So that's what I want you to do with me first. Let's go ahead and do that. We're going to take 3.5 and we're going to multiply that times 7. And then I'm going to multiply 10 to the negative 3 times 10 to the 5th power. There's also a property that says I can add in some parentheses and regroup. What property allows me to regroup?
Associative.
Associative. Associative is done with the parentheses. Now, Emily, when you say distributive, that would be if we had a number outside of the parentheses and we were distributing it or multiplying it times everything inside. That would be the distributive property.
So, with that, since, wouldn't it be you'd add the negative 3 and 5?
Yep, you're exactly right. Let's go ahead and do that. If we have 10 to the negative 3 times 10 to the 5th, we've done that. So we took a quiz over the other day, isn't it? What do we do to those exponents when we multiply our bases? Add them. And negative 3 plus 5 is 2. Let's go ahead and multiply 3.5 times 7. What is 3.5 times 7? So my next question to you is this in scientific notation?
Yes.
Yes.
No.
No, wait, no, it's not, because it's not done.
Matching.
What's wrong with what we have?
The decimal is not.
Go ahead, Melissa. To be in scientific notation, we have to have exactly one digit on that left, don't we, on the decimal? In other words, this number here needs to be greater than 1, but it has to be less than what number?
10.
10. Did you guys remember that from science? Greater than 1, but less than 10. And 24.5 is bigger than 10, so it's not quite right.
So you'd have to move your decimal over one more time to get 10 to the 3rd power.
Well, hang on just a second. My suggestion at this point is let's go ahead and put it into standard form, because I'm asking you about standard form and scientific notation, right? Some people will think, well, didn't I just move my decimal once and add 1 to the 2? Well, you could, but are you sure you're going to add 1 to the 2, or are you not going to subtract 1 from the 2? It gets confusing, and it's hard to remember. So I would recommend, so let's change to standard form, then we can go back to scientific notation. That's fairly easy to do. And they're asking for both forms anyway. So let's put this into standard form. We have a positive exponent. We want to make our answer really big. What am I going to do with that decimal to make our answer big? To the right. 1, 2 places. How many zeros do I add? 1. So I have 2,450. That's our standard form. We can easily go back to scientific notation. Let's move our decimal starting here. We're going to have here, and we're going to move to the left. 1, 2, 3 places. So it's going to be 2.45. I don't necessarily need that 0. Times 10 to what power?
3rd.
Is it 3 or is it negative 3?
You're going to left.
3
It'd
would
be negative.
It'd be a positive 3.
Yeah, positive 3. This number right here, yesterday we discussed this. We said if this is a big number,
It'd be a positive.
it's going to be a positive exponent, right? If this had been a little bitty decimal number, then this would be a negative.
Actually, the whole left and right thing actually threw me off yesterday. So I had to go back to when I remembered how to do it to figure it out.
But if you can just remember, if it's a big exponent, it's going to be a, it's a big number, it'll be a positive exponent. Decimal number, small number, is going to be a negative exponent. That, to me, is the easiest thing to remember. Instead of going left and right, because that sometimes gets confusing. Look at the next example, example B. Same type of situation, we're multiplying two numbers that are written in scientific notation. Again, I would not recommend putting these both into standard form and then multiplying the results. It sometimes will work for you, sometimes it's going to be way too big to even calculate. So the first example, or the second example I should say, we can rearrange, correct? Use that associative property that we just talked about. We have 6.5 times 8.7 times 10, oops, times 10 to the 12th times 10 to the negative 15. What is 6.5 times 8.7?
56.55.
56.55 times 10 to what power? What are we getting at here? Negative 3. Is this currently in scientific notation?
No.
Not quite. We have a digit issue, don't we? We have 2 digits on the left of our decimal, whereas we need 1.
And it's not standard.
It's not in standard form either. What's going to be the easiest way to put it into scientific notation? Let's go to standard form first, and then we'll put it back into scientific notation. So our exponent here is negative. What does that mean our answer is going to be? Our standard form, is it going to be a big number or a small number?
It's gonna be a small number.
It's small. So what direction can we move that decimal to make it a small number?
Left.
The left. 1, 2, 3. How many zeros do I need to add? 1. I am going to add an extra 1 to go on the left of that decimal. And Zeke, this is what you were asking about, to make sure you add in that extra 0. So 0.0565. Please include all of the digits in your number, don't round. So let's go backwards. Let's go to scientific notation now. We're going to move our decimal to the right 2 places. So 5.655 times 10 to what power? And why is it negative 2 as opposed to a positive 2? That's a small number, isn't it? So our exponent's going to be a small number. Any questions so far? Let's do one more to do together, and then we'll look at some division. Example C is where we're at right now. But you guys have taught me through. What would you do first here?
Multiply your decimal.
Okay, multiply those decimal answers. 1.95 times 7.8. And then multiply your tens. I'm sorry, Logan, what did you say? Okay, you- 15.1.
15.21.
15.21 is what I have as well. 1.95 times 7.8 is 15.21. Times 10 to what power?
Negative 6.
Be careful, negative 8 plus a negative 2. Negative 10. Is this in scientific notation? No. We could easily put it into standard form though. We're going to move our decimal in what direction?
Left.
Left. We have a negative exponent, so we're looking to get a really small number. I'm going to move it 1, 2 places, and then I'm out of digits. How many zeros do I have to add in there? 8 plus our extra. That 0 point, now I'm going to add 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 5, 2, 1.
So what would that number actually be?
It's a good question. Why don't you see if you can look that up and figure that out for me? You do that?
I'll check it next hour because I have computer access next hour.
Maybe you could Google it.
Always got spare time in this airplane class.
I think that's now we're going to look at. What direction are we going to go with that decimal to change it back to scientific notation? To the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. 1.521 times 10. What did we say? 9? Is it positive 9 or negative 9? Negative. This is definitely a really small number, isn't it? What are some situations where we would need to use a number like that that's really small?
Calculating time, maybe.
Okay, calculating some time. What else?
Maybe a percent.
Possibly. Hair. What if we wanted to know how many meters wide a length of hair was? Would that be a really small number? The thickness of our piece of paper that we're writing on? There's lots of different times in science, or I always say science, but lots of different times in life where you may have a really, really, really small decimal, and that's feasible. Okay, it may not be something measured in feet or inches, it may be something measured in much smaller terms. Any questions on the multiplication portion of this? Please flip your paper over to the back side where there's some division. We're going to take the same approach that we did with multiplication. We're going to use our exponent rules here. Looking at example D, we'll kind of walk you through this one. In example D, I want to think of those as numbers that we could divide. Could we easily divide 3.066 by 7.3?
Yeah.
Sure we could. What is it? Thank you. 0.42 times 10 to what power? What do we do with those exponents when we divide? Subtract. 8 minus 3 is 5. Is this in scientific notation?
No.
Close, but not quite, is it?
Too far.
We have one digit. Somebody's going to argue that we have one digit on the left, but that digit can't be 0. Our decimal number has to be greater than 1 and less than 10. So let's change this to standard form. Our exponent is 5, positive number. So we want to make our answer really big. What direction will I move my decimal to make it big? To the right. 1, 2, and then how many zeros will I add after the 2?
3.
3. Very good. And Steel would be proud of you guys. You guys are kicking butt on this scientific issue.
Already covered it.
Huh?
Already covered it in that class.
That's good. She'd be proud of you. I'll email her and give you guys a little bit of push. Sorry, she did get you guys learned something. Scientific notation. Let's go the other direction. What direction am I going to move the decimal this time? 1, 2, 3, 4 places. 4.2 times 10 to the 4th power. Why is it positive 4? Went to the left. This is a big number. 42,000 is a relatively big number. So our exponent is going to be a positive answer. Example E. Let's keep rolling. This next problem. Let's go ahead and divide. Let's take 2.3958 divided by 1.98. What'd you get? 1.21. Times 10 to what power? Negative 5. Is this in scientific notation? Yes, we got lucky on this one, didn't we? These others we haven't been so lucky. We got one already in scientific notation, so just bring it down. So you're confused why is that scientific notation? Or how we got our answer?
I was already, because the decimals, it's already out front. Yep, I got you now.
This number right here
1, yep.
is between 1 and 10.
I see.
Where are the hips a break?
Let's go to standard form. So we're going to work backwards here. We have it in scientific notation. Let's put it in standard form. We have a negative exponent.
Move to what?
We're going to move it to the left because we want to make a really small number, don't we? So we're going to move our decimal one place, and then how many zeros am I going to add? 4 plus the extra, so 0 point, and then 4 zeros. 1 through 1. Sometimes they'll be next to you, but probably not as much as you would like. I'm going to make you put it in standard form first.
Get it, it's 0 problems.
You want more of those in here. Me too. They're easy to grade too. I like this. We have one more example here. Let's try this one. Actually, I want you guys to try this one if you would, please. Why don't you go ahead and work this on your own? When you've got your answer, you can just raise your hand and I'll check your work, make sure you are correct. guys, very good, very good. I think all of you got your answer to be 9 million. And it was 9 times 10 to the 6th power. Very good. All right, just a reminder that if you have a negative exponent, that's going to make your answer really small. If you have a positive exponent in scientific notation, that's going to make your answer really big. Today on your homework, I am asking you to do both standard form and scientific notation, just as the directions will indicate. I do have some problems for you to try. They're out of your book. I am going to adjust this for a second. I believe I've already done that, so I'm going to do something similar. So 11 through 18 all, and 36 to 52 evens. If you would like to partner up and work for the remainder of the hour, I'll let you do that today, as long as you are on task and working.